So in the last video we were discussing reference angles, and reference angles are always acute angles, so angles between 0 and 90 degrees, measured between the terminal ray of the given angle and the x-axis. So for example, to determine the reference angle for negative 440 degrees, and you could pause this presentation and try this one. So I'm going to begin by sketching negative 440 degrees. So here's my angle of negative 440. Well, negative would mean clockwise direction. All the way around the circle would be 360. And then to get to 440, I need to go 80 more degrees. So this last part of the angle here, that's 80 degrees, and that's the reference angle. That's the acute angle between the terminal ray and the x-axis. So that reference angle is 80 degrees. So one more, you could pause this presentation and try this problem. So sketch the angle, then find its reference angle. So I'm going to begin by sketching minus 11 pi over 3. So negative would mean that I'm going to rotate in a clockwise direction. 2 pi is all the way around the circle, so 2 pi would be 6 pi over 3 as a fraction. So if I start here and go all the way around the circle once, that's 6 pi over 3. Now halfway around the circle is pi, or 3 pi over 3. So I'm here at 6 pi over 3. I'm going to go 3 pi over 3 to get halfway around. That's 9 pi over 3. To get 11 pi over 3, I need to go 2 pi over 3 more. Well, 2 pi over 3, that's 120 degrees. So that's going to leave me here as my terminal ray, 120 degrees with a reference angle of 60 degrees, or pi over 3 radians. So that's my reference angle, pi over 3 radians. The acute angle between the terminal ray and the x-axis. So this is just the process to finding a reference angle and also to evaluate a trigonometric function of any angle theta. It's really the process to evaluate the trigonometric function of any angle theta. The first step is to find the reference angle, evaluate the trig function for the reference angle, so determine the sine of theta prime and the cosine of theta prime, and then consider the quadrant when I determine whether the value of the trig function is positive or negative. So if you remember, definitions for a trig function like sine is y over r. So r is always positive, so the sine of the angle is going to be positive or negative depending upon whether y is positive or negative. And y is positive in the first and second quadrants, and y is negative in the third and fourth quadrants. Similarly, cosine, that's defined as x over r. Once again, r is always positive, but x will be positive or negative depending upon the quadrant. X is positive in the first and fourth quadrants, which is why cosine is positive in the first and fourth quadrants. And you can see a similar process would allow me to fill out the rest of this chart, determining where the trig function values are positive or negative. So to evaluate the cosine of negative 150 degrees, I'm going to determine the reference angle. Then I'm going to evaluate the trig function values of that reference angle. And then I'm going to determine the sine of those values based on the quadrant. So I'll start by drawing negative 150. Negative means clockwise. So here's negative 150. Here's my terminal ray. And here's my reference angle, 30 degrees. I realize I have a 30, 60, 90 right triangle. The ratio of sides is 1 to square root of 3. But in the third quadrant here, both the y value and the x values will be negative. Once again, r is always positive. So the cosine, that's x over r, that will be negative root 3 over 2. Negative root 3 over 2. To determine cotangent of 16 pi over 3, once again, I'm going to begin by sketching the angle. 16 pi over 3. Positive 16 pi over 3 means a counterclockwise direction. So 6 pi over 3 is a full rotation. 12 pi over 3, that's another 6 pi over 3. That's another full rotation. So I'm at 12 pi over 3 now. 3 pi over 3 will bring me halfway around the circle. That's now 15 pi over 3. I need one more pi over 3 to get to 16 pi over 3. There's my reference angle, pi over 3. That's radians. That's 60 degrees. So this is once again a 30, 60, 90 right triangle. Ratio of sides. Third quadrant tells me that both the x and y values are negative. Cotan is x over y. So that'll be negative 1 over negative root 3. Cancel the negatives and rationalize. I'm left with root 3 over 3. So to evaluate the function without using a calculator, so I'm going to begin once again by sketching the angle, negative 210. So here's negative 210. I'm going to determine the reference angle. Reference angle is 30 degrees. I have a 30, 60, 90 right triangle. Ratio of sides, 1, 2, square root of 3. In the second quadrant, the x value is negative, the y value is positive. Cosine is x over r. So cosine is negative root 3 over 2. Negative root 3 over 2. That's the cosine of negative 210. Evaluate the function without using a calculator. You can pause this presentation and try this problem. So I'm going to begin by drawing the angle. So 9 pi over 4, positive angle, counterclockwise direction. 8 pi over 4 would be a full rotation, full circle. So one more pi over 4, that's 9 pi over 4. That gives me a pi over 4 reference angle. This is pi over 4, which is also 45 degrees. This is a 45, 45, 90 right triangle. Ratio of sides, 1, 1, square root of 2. Secant, that's r over x. So r root 2 over x1, root 2 over 1, or simply root 2 for the secant of 9 pi over 4.